In this video, we're going to continue our notes on Chapter 7, and I want to begin, before we get into the concept of atomic radii, I want to quick revisit a concept that we learned in the last video, and that would be our Z effective. Okay? If you recall, the Z effective is basically the actual force that any given electron is going to feel from the nucleus. Okay, let's recall the nucleus is going to be positively charged and the electrons are going to be negatively charged. So we can think about them as magnets, and we can say that the Z effective is just basically how strong is that positive charge going to be compared to the negative charge that the electron has. So I've given you some data here. Here we have our 2p block from the periodic table. We're going from left to right, from boron to neon. And right here I've given you the Z. Remember, our Z is just the atomic number. Okay, just how many protons are in that nucleus. So it's pretty straightforward, just 5, 6, 7, 8, 9, 10. But we talked about kind of how the Z effective is going to be slightly different from that, because we have to take into consideration the concept of shielding or screening by the core electrons of that atom. And as it turns out, our Z effective is going to increase as we go from left to right within the same period on the periodic table. And you can see here the data shows that boron has a Z effective of a 2.4 and the neon is a 5.8. What this means is that as we go from left to right on the periodic table, our nucleus is going to feel stronger and stronger to each electron on the outside of that atom. And as a consequence, we'll get back to our actual point here, our atomic radius of our atom is going to be affected by this idea that the Z effective is increasing as we go across the row. So let's quick recap here. When we're talking about a radius, if we have a circle here, in this case it's a positive nucleus with our electrons on the outside. We know already that we can't exactly say where the electrons are going to be in an atom, but we can say with some certainty how far away from the nucleus it's going to be. And our radius is going to be just the distance from the nucleus to the outside, the outermost electrons. So we want to know, what is the trend on the periodic table of the atomic radii? Let's move this up. Alright, so we can draw kind of just a rough sketch here of the periodic table. And the way this trend is going to work is that as we go down our periodic table, this should come with some kind of intuition for you guys, but as we go down the periodic table, our atomic radius is going to increase. So the radius is going to increase as we go down the periodic table, and this is because the value of n is increasing. And as we go, from the we'll say the 2p subshell to the 5p subshell, we're getting farther and farther away from the nucleus because our value of n is increasing. As we get farther away from the nucleus, the pull that the electrons are going to feel on the outside are going to be less and less, and we're more spread out with our electrons. So that should be pretty obvious to you. What is not obvious, though, or it may be, I don't know, is this trend that as we go from left to right, our radius is actually going to decrease. And this is all going to have to do with what I showed you above, where our Z effective is actually increasing as we go from left to right on the periodic table. So basically we can think about it like this. As we go from left to right, our nucleus is getting stronger and stronger. And remember that valence electrons aren't going to shield each other the way that electrons in the inner core of the atom are going to shield each other. So even though we're increasing our number of electrons, they're mostly going to be in the same subshell, so they're not going to shield. Meanwhile, as we go from left to right, our nucleus is getting stronger and stronger. We're adding more and more protons. Our Z effective is getting stronger. So our nucleus is gaining strength, basically, as we go from left to right. And as a consequence, what's going to happen is the radius out here is going to get sucked into the nucleus, okay? Because the nucleus is getting stronger and stronger, and it's going to suck in the outermost electrons. And so we can kind of see that as we go from left to right, as the nucleus gets stronger, the radius is going to shrink, okay? And we can talk, let's move this up. Right now we've just talked about our neutral atoms, but we can also talk about ions because they are going to be affected as well with their atomic radius, but this should be pretty obvious. When we have cations, they have a positive charge because they've lost electrons. Well, as we lose electrons, we can say that, excuse me, we are subtracting electrons, so our atom gets smaller. Conversely, when we have our anions, these are going to be our ions with the negative charge, as you recall. Our atom is going to get bigger because you're adding more particles, and it's going to expand as you add more electrons. Okay, so that should be pretty intuitive. What we haven't really talked about, though, is this concept of, let's change our color back to green here. We have what's called an isoelectronic series. This just means that they are atoms with the same number of electrons. Okay, and therefore they're going to have the same electron configuration. Now, when this happens, if we want to talk about atomic radius, we have to just look at the value of Z, or the atomic number. Remember, Z is just how many protons are in the nucleus. So, for an example, if we have an oxygen anion with a -2 charge, we have a sodium cation with a +1 charge, and let's say we have an aluminum cation with a +3 charge. Our value of Z for oxygen, remember, the value of Z is never going to change, even though it's an ion, because the number of protons never changes. So, oxygen is going to always have 8 protons, sodium will have 11, and aluminum will have 13. And we said that these are an isoelectronic series, so they're going to have the same number of electrons. And if we do the math, oxygen, if it has a -2 charge, that means it's gaining 2 electrons. So that's going to be 10. Sodium used to have 11, but it's positively charged, therefore it's lost an electron, so it should have 10. And aluminum started out with 13 electrons. It lost 3, so it will have 10. And we can go back to this concept that we've discussed before. When the nucleus is stronger, it's going to suck in the outer electrons and it's going to shrink the atom. So we would say that this oxygen here is going to be the largest. Okay, and that's because its nucleus only has 8 protons, and if we go over here, this is going to be the smallest because its nucleus is going to be stronger with 13 protons. Okay. Alright, I'm going to stop here, and then the next video we'll talk a little bit about what's called ionization energy and electron affinity.